Hello, I'm here today to talk about the honeypot project. We're discussing the prototype for our project. Currently we have two separate honeypots deployed. The first honeypot is a virtual private server, an Amazon Lightsail instance, which you can see here. It is an Ubuntu server, which has caused a lot of problems currently. Uh, Perhaps the largest problem with the project to this point has been that Amazon Lightsail instances use the latest and greatest Ubuntu version, which doesn't always work with some of the honeypot sensors that I've tried to deploy. In many instances, I have to change the installation scripts around slightly to get them to install on the server. This is because that not a lot of the scripts for the honeypot sensors are updated to the latest version of Ubuntu. The server itself has 512 megabytes of RAM. It's got one virtual CPU core and 20 gigabytes of storage, which can also be an issue on occasion depending on how many log files you have. I've filled up the server completely on one occasion. Now this is the public IP address for the instance itself. The username is Ubuntu. You connect to the server with a public-private key pair. And the only thing else that we need to really look into here would be the networking tab. You can see both the public IP and private IP address. The private IP address allows you to communicate securely with other internal resources, as in other Amazon Lightsail instances. The firewall, currently we have the entire port range open for TCP. This is so that a variety of sensors can be deployed and listed on different ports. Currently we have two sensors deployed on the server. Amun, which is a malware collector, and we have Cowrie, which simulates an SSH shell, which we will be looking into next. Okay, so now we're going to demonstrate our honeypot. We're going to do so with two different terminal windows. We're going to have one on the left where we're going to connect to our honeypot and review the log files from the interaction. On the right, we're going to log in using SSH in the same manner that a hacker would log in to our server, and we're going to see the results. So the first thing that we need to do is SSH into the server. We're going to choose the root user, and we're going to choose port 22, which is a standard SSH port. And the honeypot will prompt us for a password. It's not very picky, and it lets us in. Now at this point the honeypot is recording not only the username and password that we use, but it is now recording the terminal session that we have open currently. And it will record anything that, any command, any keystroke that we put into the server. A login banner is popped up. It says that we are on a Debian Linux machine, which we are not. This is a virtual environment created by the honeypot itself. The honeypot uses Python to create this virtual environment. It also uses a pickle file system, which is common for virtual environments created with Python. The pickle file system can be edited or modified if need be to change the structure to look like a different operating system. So at this point we can run any command that we would like as long as it's in the virtual environment. Running a couple commands here. We can create files if we would like. can remove files. We can even remove system files if we would like. Check out the shadow file. We can do basically whatever we would like to. We're logged in as root. And this is being recorded by our honeypot currently. So what we're going to do is we're going to now terminate our session. So our connection to the honeypot is now closed. And we're going to hop over to the other terminal window and we're going to see what we can find on our honeypot. Now you can notice immediately there's a difference. We use a public-private key pair to log in with SSH, so no passwords required. The username is Ubuntu, and the port that we're using is 2222 to establish our SSH connection. The reason for this is that we had to change the port numbers. We had to bind port 222 to our legitimate SSH service, and port 22 was we bound to the honeypot that we were running, the honeypot sensor called Cowrie. So now we can go review the logs. You can see some of the other Amun is there. That's our other honeypot sensor. And we can go into Cowrie. And what we will do is we will go into the log. Cowrie records everything that happens every day, every attempt at a connection. It also will record the terminal session, which we can see at the bottom here. So, and then we can play back this terminal session. And this will display what we did during our time on the server in real time. Every keystroke is recorded. Now, not only does it just keep a log of what we did in the server, it also creates the log in a couple different formats that can be used by security event managers. So, for example, if we're using the SIEM or Security Event and Information Manager called Alien Vault, then we'd be able to import our logs into Alien Vault to get a little bit better of intelligence. So there we go. That's our prototype right there for our Cowrie server. It demonstrated that we can indeed log into the server into a virtual environment. The virtual environment does capture our keystrokes. It also captures what passwords that we have attempted to use, and then it logs it to the honeypot server so that we can delve into it and investigate. We've been running it for probably about 30 days now. We haven't caught any actual hackers per se, except for maybe ourselves, but we have caught quite a few automated bots that seem to attack the server quite frequently, which we will talk a little bit about next. Okay, I'd like to show you with our Cowrie honeypot the botnet that has been attacking us quite frequently, and speak momentarily about that before we move on to our other honeypot that we've set up. We are currently in our honeypot, and we're going to play back this log for you. It goes rather quickly, but the input is much faster for a bot because it's automated. This bot has hit the server frequently since we've turned it on. It is used for DDoS attacks. Recently there was a very large website in France, I believe, that a DDoS attack was launched against using this botnet. And we've also found the source code for this botnet online. It appears that they have modified this botnet to work with SSH. It was originally designed for Telnet. It's got a typical command and control infrastructure where you have a bot that connects to a command and control server to launch the attack. And if anybody's interested, it's quite easy to find the original source code for this. I'm sure that it's been modified since online. So, and lastly with this server, I would like to show our report generator here that we have associated with this honeypot. We also use a sensor called Amun. Amun is more of a low interaction honeypot. It records attacks on a variety of ports, most notably 445 and 3389, which I believe is associated with RDP. And we get these generated reports. We've had thousands and thousands and thousands of individual incidents here from a variety of countries. These typically aren't hackers, these are more botnets trying to attack a variety of ports. You can see that we have some from the Ukraine here, and I believe that we also have people from India. But they typically hit the same ports, and they are trying to execute shellcode to penetrate the system. 445 is quite popular. As you can see, we can go through here, and we've had thousands of these types of connections from botnets. Occasionally you will get a botnet here that will also try to attack port 23, but this is part of the report software that we also set up in the process along with HP feeds, so that we can keep track of where the attackers are coming from, what ports they're attacking, what the shellcode that they're using. That's actually also stored on the server, which I can show you here. If we go into our Amun, we can look for shellcodes. And we can see like the shellcode manager log, and we can read through the actual hex dump that they have attempted to use on the system. And these are the hex dumps of the raw data that was captured on each of these ports. So using this sensor, we've been able to log thousands of connections on a variety of ports. We've been able to capture several botnets that have tried to log in with SSH and perform remote commands on our server. So we're well on our way, and we have one other low interaction honeypot that we set up that we will talk about in the next video. Okay, so now we're going to discuss the second honeypot that we set up. This one is called Honey Drive, and this is actually a virtual appliance that is installed on a hypervisor. We had to convert the virtual appliance from one hypervisor to work on ESX. Um, Once that was done, it was pretty simple that I just had to install um, an ESX server here locally, and then I could import the appliance onto the server and fire it up. This server runs DNA, which is a another low interaction honeypot. Its purpose is to capture malware. Um, and you can see here that we have it running in on a ESX server, and this is actually it pulled up here remotely. The advantage of this honeypot is that it provides us also with another nice web interface that we can check out to see how many connections we have. Currently we're at 38,000 and we're still going strong. It also categorizes the attacks by country. We can look at the map of the world. It shows us where the attacks are coming from, which is important. Secondly, it shows us what ports are most frequently attacked. We can see that port 23, which is Telnet, is quite frequently hit, as well as 8080, 1433, but the port that's probably the most interest is 8333. This is the one that we're getting the most traffic on. This is for Bitcoin. We are not connected to a Bitcoin node, nor have we ever been. So the amount of Bitcoin traffic with people scanning to see who is running a Bitcoin node and probably attempting to steal Bitcoin is what my guess is. That is quite interesting to me. And then a breakdown of the type of services that they're trying to exploit. But unfortunately, we've not been able to download any malware. The most complicated part of setting this up and/or what we overcame was the importing the virtual appliance into ESX because it was set up for another format. So we are also getting threat intelligence from this scanner also. It is set up on my home network in the DMZ. And I am just capturing traffic there that's coming into my home network. Thank you, and we will continue on with our results and conclusions. Okay, so let's go over basically what we've accomplished, recap any problems we've had, show any changes that we might need, and plan our next sprint. So we've configured 2 honeypot servers. We've also configured the reporting software, several different sensors on each of these honeypots, and we've tried to adjust them to the ports and also to set them up in a way that a hacker would find them interesting. Unfortunately, the results of this have been that we've got a lot of automated bot traffic, which keeps hitting our servers. So what we're going to need to do is we're going to need to change it up a little bit as far as how we're doing business if we want to attract a real hacker, and have a real log of some advanced threats. So what we're going to go from here is that we are going to look up at setting a little bit different setup for our light sail instance. In fact, we're going to be using 2 instances, and we're going to try to kick it from what we have now, which is more or less what they call a medium interaction honeypot, where it uses a virtual environment. What we're going to create is a high interaction honeypot, which is a little bit more dangerous. We're going to be playing with an actual real system to configure and set up a real server. And then what we're going to have is a computer set up in the middle to act as a proxy, and that will perform a man-in-the-middle of attack. So that is our next goal. Is in the project that we're going to be using, or software that we'll be using for that, is Han SSH, um, and that will allow us to basically perform a man-in-the-middle of attack between the attacker and our high interaction honeypot. Um, so that is the next phase of our project. We'll also be looking at getting a static IP for that account instead of having it bounce around. And we will also have to set up a DNS zone for the project also with that, so that we can properly route the traffic. We'll also be working on a little bit better reporting software. That has been quite problematic to keep that up and operational. What we found out that it's not a good idea to run your honeypot and then to also run the analysis software on there, along with like the HTTP interface. That might scare some hackers away for one, but more importantly, that some of the honeypot software on occasion seems to break the HTTP portal where you can view your attacks. So that's also why we want to logically separate the actual honeypot itself from the logging and monitoring. So we will need two servers. We're also going to look into a little bit more as to why we're getting so much traffic onto Bitcoin, and that will basically be our next sprint, if you will. Other problems that we encountered throughout the project. The most difficult part of the project has been to deploy on the latest version of Ubuntu. A lot of the honeypots are still running on older versions of Ubuntu and Debian, which aren't available in these AWS instances. So there were some minor changes to both the installation scripts. We had to install some older versions of some software packages like MongoDB in order for that to work with this the honeypot system that we're using. We also had an instance where we collected so many logs of events that, and so much hex dumps from these attacks, that we locked up the server. At that point, we had to log in and delete and free up some space, so we lost a few logs in the process. But the overall foundation and theory was sound. We are collecting information from these sensors. The work was performed solely by me on this project, and it will be moving forward. And like I said, we're going to take the lessons that we learned from this honeypot, the lessons that we learned from looking into the source code from these bots, and we are going to try to come on with the next build with a little bit more high interaction, and I'm going to try to incorporate some honey tokens also that we can watch come across the network, and we will go from there. Thank you very much.